Well, good afternoon and welcome to the first of our Spring Science Speaks seminars. My name is Jeff Schlatter. I'm the director of the UC Davis Tahoe Environmental Research Center. To learn more about TURC, the research we conduct here and around the world, the public education and citizen science programs we provide for local and regional communities, and our work with government agencies in the Tahoe Basin and beyond, please visit our website, tahoe.ucdavis.edu. You can also find out how to follow us on social media, how you can participate in our activities, and help support the work we do, including these monthly lectures. For those of you interested in learning about being a docent at TURC, a new docent training program is already being planned for the spring. Our goal today is to facilitate interaction, dialogue, and discussion, something that Zoom does not excel at. Despite the technological limitations, we will be attempting to address questions at the conclusion of today's presentation via the Q&A function on Zoom, not the chat function, Q&A. The only way to ask questions or make comments is to type them into Q&A, and our presenter will try to get to as many as possible. Before I introduce her, I wanted to alert you to upcoming Science Speaks lectures. April 22nd, Conspiracy Theories and American Democracy. So if you're a fan of democracy, you won't want to miss that. And May 13th, Rethinking Fire, Cultural Burning and the Art of Not Fighting Fire. So today's seminar, Calculating the Cost of Climate Change, truly cuts to the bottom line. What are and how do you evaluate the cost of climate change and our dependence on carbon? Regardless of your feelings about climate change, there is a cost we are already paying. Dr. Fran Moore is an assistant professor in the Department of Environmental Science and Policy at UC Davis. She has worked across the climate sciences and economics to improve estimates of climate change costs in the agricultural sector and the loss of ecosystem functioning and extinction risk. The goal is to predict the real costs of climate change by including things that add value to the health of the planet. Dr. Moore, control of Zoom is yours.
Thank you very much. Thank you for having me here, and thank you to all the attendees for kind of showing up. So first of all, I have to apologize. I lost power in my house this morning, and that meant because all my files are stored in the cloud, I also kind of don't have access to any of my files. And so I don't have a PowerPoint presentation because of that, but I have prepared a very organized kind of talking presentation, which I thought would actually be really nice because sometimes you can really get kind of PowerPoint fatigue. And so I'm just going to kind of talk about this issue of how do we try and measure the cost of climate change? How did that go into policy? What are some of the things that are missing in that? And then how does my work contribute to it? I'm going to try and talk for about kind of on the order of kind of half an hour to 40 minutes, and then hopefully leave plenty of time for Q&A at the end. So climate change, as we know, is kind of well established as a scientific phenomenon, right? We've known for kind of well over 100 years that putting CO2 and other greenhouse gases into the atmosphere is going to change the radiative balance of the planet and lead to warming. The economic question of kind of, well, what does that mean for people, for human well-being, is a much more recent question. And it's also, I would say, still kind of poorly understood. There's, for a long time, there was even a question of like, is it even bad? Like what sign are these costs, right? Maybe it's a benefit. Svante Arrhenius, who was one of the kind of original scientists kind of demonstrating the greenhouse effect, kind of thought that it might be a positive thing, right? He lived in Sweden and he thought it might be nice to have a little bit warmer temperatures in Sweden. But as we've kind of learned more about what this rapid change that we're kind of that we're doing to the climate system, what effects it has, it's increasingly clear that these are damaging effects. And the question then becomes, well, how damaging is it, and how do we try and calculate that? this question of kind of how bad is climate change is a really tough one if you think about it, right? If what we do is we take, you think about how would we even go about calculating this? When we put CO2 into the atmosphere, the CO2 goes around the world, right? It stays up there for decades, if not centuries. It contributes to different kind of forms of climate change around the world, which in turn have effects on a whole host of different people, communities, economic sectors, and ecosystems. What we're trying to do when we try and estimate these aggregate costs of climate change is essentially we try and calculate what all those things are and then add them up. And that sounds like it should be simple, but it's definitely not. One important thing for kind of understanding this issue is to when I talk about economic costs or the kind of the cost of climate change, these aren't just what you might think of as kind of things we buy and sell on an everyday basis. And so economics at its most kind of fundamental level is about human welfare. And so really anything that affects human welfare would count as an economic cost of climate change. And so that does include what we would call market goods. So that's things that we're used to buying and selling on an everyday basis. And so that includes things like agricultural damages, losses to coastal infrastructure, things like labor productivity. And those are relatively easy to value because they're things that we trade in a market on an everyday basis. But these other costs that we also want to include in our estimates of climate change costs fall outside that market, that kind of market mechanism. And these might be some of the most important, long-lasting and widespread damages from climate change. And so here we would include things like death and disease, changes to ecosystem health, to recreation, to human comfort, as well as historic and cultural values. And you can just see from that list, like these are some really, really important things, and they're very difficult to value. And so environmental economists in particular have come up with a range of techniques for trying to value these non-market goods and trying to kind of in order to try and understand, well, how do we quantify these costs of climate change? And not just climate change, but these techniques are relevant to other environmental problems too, like air pollution and water pollution. And so when we talk about the aggregate cost of climate change, we're talking about all those things together. And so one kind of legitimate question then is, well, why might we want to do this? Why is it important to try and add up all these impacts? Isn't it fine if we just understand this thing is bad, we should avoid it, and kind of leave it at that and kind of go ahead with climate policy? And I would say that's definitely a very legitimate question. It's not at all obvious this is a sensible thing to do, to try and add up all these things. But in the US context, we do have the federal government has a cost benefit analysis requirement. And so this requirement dates back to the Reagan administration, who in the 1980s kind of required federal agencies, if they're undertaking new laws, to subject those new regulations to a cost benefit test. And so if you're an agency kind of thinking about a new regulation, you have to go through a formal process that's kind of overseen by guidance from the Office of Management and Budget that adds up tries and quantifies the cost of the regulation and then tries to quantify the benefits of it. And so what this requirement has done, it was originally thought that this requirement would be a kind of regulation cutting tool for the federal government, that you would kind of show that these regulations were very costly, and you wouldn't be able to get them to pass the cost benefit test. But in response to this requirement, what you've seen is a lot of work within the environmental economics community working to better quantify what the benefits of these regulations are. So these are regulations that kind of affect pollution, might affect health and safety. things like that. And what we found, like now we are better able to measure the benefits of these changes. These benefits on average are really large. It's particularly true of air pollution, where we're finding kind of more and more damaging effects of even very low levels of air pollution. And so this cost benefit test is kind of required to be used across the federal government. So what does it have to do with climate change? Well, in 2008, there was a court decision that said in these cost benefit analyses, you have to consider climate change, right? So if you are doing a regulation that has any effect on greenhouse gas emissions, you can't just ignore the cost of those regulations. You have to kind of put a number of 0 on it would be would be arbitrary and capricious, which is this legal standard that that federal agencies kind of are not allowed to be arbitrary and capricious when they make their regulations. And so this court decision then kicked off a process within the federal government of trying to decide, well, we have to put some number on this cost of climate change, and what number should that be? And so this process focused on a particular number, a particular value called the social cost of carbon. And the social cost of carbon is it's the externality, so it's the costs associated with emitting 1 ton of CO2. So imagine kind of we have some emissions of greenhouse gas emissions going out into the future, and we just emit 1 extra ton. And then what we try and do is we try and calculate, well, what's the present day value of all the costs associated with that ton of CO2 as it stays up in the atmosphere for centuries in the future and kind of continues to contribute to climate change around the world. And so in 2010, the federal government kind of first came up with a value for this based on existing models at the time. And the number they came up with was about $30 per ton of CO2. And then since then, there's been kind of various updates. The number has gone up somewhat. And then the Trump administration made a number of changes to the value, which cut the value by about 90%. So it went down to almost just a dollar per ton almost. Just recently with the new Biden administration, all those changes have been reversed. There's been a kind of revised number and it's gone back up to $50 per ton. And there is kind of right now an ongoing process to review within the Biden administration, the models that they're using to come up with that this social cost of carbon value. But it is a value that will be applied every time a kind of a federal agency is kind of seeking to do something that will affect greenhouse gas emissions. And it's going to be the number that is applied in this regulatory cost benefit regulation. It's also a number that's increasingly used by states. So California at the moment has a process where it's trying to figure out, what social cost of carbon to use. It might kind of modify it, the federal process in various ways. Canada also uses it. Different versions of this number are also used in parts of the European Union and the UK as well. And so, well, what's the issue here? Well, the issue is that it's widely understood that the kind of science underpinning the representation of climate change impacts within these models is really out of date and is really kind of not kind of sufficient to support the use in regulatory analysis that these models are having at the moment. If you kind of try and really trace back where the information about climate change impacts come from in these numbers, you can really trace it to science that was done in the 1990s or even the late 1980s. And our understanding of climate change impacts has really evolved since then, but none of that is really incorporated into these models. And part of the reason why is that this process of valuing these climate change impacts, which is what you need to do in order to incorporate it into this process, is really challenging. It's challenging and it's also interdisciplinary. So it sits right at this boundary of kind of climate science and environmental economics. And that's like not many people are kind of happy kind of working in that space. So I want to take just a couple minutes and talk about, well, what I've talked about, these models that are used to do this work, and it's worth just spending a minute to talk about, well, okay, what exactly do these models do? And so there's just a few of them. So typically the federal government used 3 different models. They were all originally developed in the 1990s. They were principally developed by kind of just one person, each of them. So they're really just kind of 3 people kind of, you know, in the 1990s, kind of working on this problem and writing essentially academic papers, you know, that were really never intended for the kind of regulatory impact they're having at the moment. What these models do, they're very simple, they're very small, and what they try and trace the evolution of greenhouse gas emissions, the evolution of the economy, and the feedback from the climate system back onto the economy. So they typically have a very kind of simple representation of socioeconomic trajectories. So those are things like population growth, economic growth, growth rates, and then some representation of what that then means for emissions and economic production. From the emissions, there's a very simple carbon cycle and climate model. So you might be familiar with kind of the type, you know, you might have heard of these models that climate scientists use, and they run on like supercomputers, and they take like years to run, and they're incredibly detailed, and they have all these kind of fluid dynamics equations kind of embedded within them. None of that is in these models. They're literally the carbon cycle and the climate models they have might be kind of 10 equations at most. So they're a very simplified representation of the climate system that lets you go from emissions to some kind of understanding of what happens with temperature. And then they're also trying to represent, well, what does that temperature change mean for the human welfare? And human welfare here kind of incorporates the kind of market goods that I talked about, but also those non-market goods as well. And here these models rely on these things called damage functions, which relate, it's a simple representation of these climate change impacts. And so they're really kind of simple functions that, you know, for a given amount of temperature change, how much is the loss in economic welfare? And these damage functions kind of are supposed to summarize everything we know about climate change impacts in this really kind of simple function. And then finally, you have the stream of damages that go out into the future, because each ton of CO2 kind of sticks around for a long time, right? And it has this kind of this impact on human welfare kind of way out into the future. What we want to do is we want to take all those future costs and kind of convert them into an equivalent cost today. And this is where this process of economic discounting comes in. And so what the discounting does is it converts future costs into equivalent present costs. And if you think about, you know, well, why do we do this? Well, one reason is for people, things that happen in the future are valued differently than things that happen today. You know, if I were to say, well, you know, I can give you $5 today, or I can give you $5 5 years from now, like that $5 today is just worth more to you for a whole bunch of reasons than the $5 in the future. But this discounting, when it comes to climate change, it raises a whole host of both economic and ethical questions about and to do with the fact that we're discounting costs that accrue to people far in the future. So it accrues to future generations who don't have a stake in our decision making today. They kind of don't have an active voice in how we decide on climate change today. And that's, if you follow climate change, and certainly if you've kind of read at all about the economics of it, you've probably run into this discounting question. And it is important. It does affect the magnitude of these damages quite significantly because so much of them happen kind of out into the future. And it's controversial, and there's been a lot written about it by both economists and philosophers. So that's what these models do. Sometimes they're termed integrated assessment models. Sometimes they're called cost-benefit integrated assessment models, because there are other types of models called also called IAMs. And so, well, what are the problems with this this framework at the moment, and what are some of the issues? And so, really, in the last 10 years, we've seen a lot of research, kind of, you know, prodding these models, poking them, and really trying to like improve and better understand kind of what drives these social costs of carbon estimates. And this is where a lot of my own work has happened. And so I'm going to just pull out a couple kind of key points that I think arise from that literature, some things that we've learned about why we might be a little bit skeptical of some of the numbers coming out of these process. So one is, as I mentioned before, is that there is a very outdated scientific literature here. And, you know, so I went through one of my papers written about 3 years ago, really looked at if we were to take a more recent understanding of the impacts of climate change on agriculture in particular, and tie it to the findings from the IPCC report, where they really review a lot of papers that have looked at how does temperature affect yield and how does CO2 fertilization affect yield. And if we were to take that literature and kind of try and understand the economic consequences of it and incorporate it into these integrated assessment models, what would that do? What we found was that this more recent understanding of how climate change affects agriculture, in this case, more than doubled the social cost of carbon coming out of one model. And that's quite surprising if you think that agriculture is only one piece of climate change damages. It's actually kind of not even what we would think of as a particularly like large piece. You know, often kind of mortality estimates are kind of very large. And so the fact that the whole social cost of carbon doubled when the whole social cost of carbon includes kind of everything was really quite surprising. A big reason for it is that we used to think that, firstly, that CO2 fertilization would be quite large, and so that benefits crops, and that warming itself would be beneficial, at least in some regions. And more recent agronomic studies have shown that warming is more damaging than previously thought, and is more damaging in more places than previously thought. And the CO2 fertilization effect, while important at low levels of kind of more carbon dioxide, it levels off very quickly. And so what that means is that the net effect of these two things for agriculture is quite negative, and certainly much more negative than is kind of currently being represented. So a second kind of really important piece that has come out in these studies about what is potentially missing in these models is an assumption that there's essentially kind of no effects of climate change on economic growth. And this is a critical but rather buried assumption in these models. Essentially, these models assume that kind of the economy continues to grow out into the future, and that climate change might kind of decrease the output in any given year, but that growth rate, where the growth rate is determined by things like technological progress and a growing population and a kind of growing capital stock, that those things that are fundamentally drive economic growth are not affected by climate change. There are reasons to think that that is not true. So if climate change damages, if you have storms or extreme events that damage critical infrastructure and damage, therefore, the capital stock, or if you have effects on this technological growth rate, which could come through a number of different pathways, then that assumption is kind of going to be violated. And what happens then, if kind of you allow climate change to affect the underlying growth rate of the economy, then those damages are persistent, and therefore they are cumulative over long periods of time, and they add up to much, much larger numbers kind of over the course of a century compared to the kind of the relatively minor types of damages that were being considered by these models kind of until very recently. And so there is some statistical evidence in the historical record that suggests these growth rate damages kind of might exist. And these are still highly uncertain, but it certainly suggests that certainly in warmer countries, potentially in poorer countries, but also potentially in richer countries too, that increases in temperature could depress the growth rate. And in a paper about 5 years ago with a colleague of mine at the time, we took some of these statistical findings and we incorporated them into this integrated assessment model. And what we found was exactly this. This is really important. And these could increase the social cost of carbon by 800%. So increase it by 8 times. And what that does is it completely changes the cost benefit analysis of emissions reduction. So whereas before you might think that a kind of reducing, it might be worth it to kind of do a very gradual kind of ramping down of emissions. If you have these growth rate impacts, the optimal climate policy is to do very, very near-term, very ambitious emissions reduction. A third reason, a third thing that kind of people have pointed out is really missing in these models is a kind of representation of tipping points and a kind of there's really no rich representation of uncertainty, potentially catastrophe in the future. And this is one of the key characteristics of climate change is that these damages, these impacts are highly uncertain. And we kind of we know that we're going to be surprised, but we don't necessarily know how or why, and we know it's probably going to be bad. I think is probably a fair characterization of the kind of exactly what we know about these things. And none of that is really represented in the damages in these estimates of climate change costs right now. And doing that, it's inherently difficult to do, right? You're trying to take something that we know is uncertain. So how do you try and model it? But if you do, and in particular, if you have a kind of an accurate representation of people's risk preferences, so people tend to be risk averse, right? And so if people are faced with these situations where there's high uncertainty, that's very damaging. Like people really try and avoid those kinds of situations. And this is to do with representing the utility function in these models. And if you kind of do a better job of that, and you actually represent how risk averse people are, the total cost of this uncertainty can be very high. And then finally, and what I'll spend the kind of the rest of my talk kind of focused on is this question of ecological costs. And this is some work that I have been doing right now with my PhD student, Bernie Bastian, who's a PhD student in the geography program at Davis. And here what we're trying to do is we're trying to really improve the representation of climate change damages to ecosystems, and particularly to understand, the costs of that, and therefore how should those costs kind of feed into this aggregate value of the social cost of carbon. And to do this, we have to kind of, think fundamentally about, well, what benefits do people get from ecosystems and from the natural world? And we think there's kind of really kind of two classes that these goods fall into. On the one hand, there is use values, and so these are things that you yourself kind of might directly benefit from. These are the kind of whole category of kind of ecosystem services might fall within this category of use values. So these are things like kind of recreating in natural areas or kind of enjoying the kind of aesthetic value of them, as well as more practical things like water filtration or pollination, all those things that we think of as ecosystem services. On the other hand, there is this category of non-use values, which are recognized but debated by economists. And so these are values that people hold. So if you ask them, do you care about these things? People will say yes. But they do not necessarily kind of ever directly consume or benefit from these things. And so this category of non-use values primarily includes things like existence and bequest values. And so that means it values that people hold simply over the existence of species or of ecosystems that they might never see, they might never visit, they might never eat, right? They might never kind of interact with in any way. And yet they kind of place a value on the kind of continued existence of these things. And a bequest value is in the value that one holds in terms of being able to pass that existence value on to future generations. And so these are both, you can think of these two types of goods as both derived from a stock of natural capital. And so this is where we get into extremely kind of abstract world of trying to represent this kind of the rich kind of diversity of ecosystems and the benefits people get from them in this very, very simple kind of climate economic model. And then if we think that, so these benefits come from the stock of natural capital, and then if climate change affects natural capital, then that's going to have in turn an implication on these for these values going out into the future, and it's going to have a cost. And so, well, how does climate change affect the stock of natural capital? Well, there's a number of things, that ecologists are kind of increasingly kind of knowledgeable about what climate change is going to do. And so if we think again in terms of these two types of goods, so use values and non-use values. So on the use value side, well, we think climate change is going to disrupt ecosystems. It's going to move kind of terrestrial vegetation. It's going to shift species around in such a way as to potentially really disrupt the flow of ecosystem services that people derive from natural systems. And so some examples of this is kind of these really widespread forest die-offs that we've seen in really around the world, which in many cases have been associated with climate change, either through drought or through climate change pest outbreaks associated with warmer temperatures. And then on the non-use side, we know that while climate change is going to place many species at increased risk of extinction, and the estimates are somewhere on the order of, depending on the amount of warming, but kind of between 5 and maybe 20% at the very high end of species might be kind of really at risk of eventually going extinct. And this is a major, if we think about these existence values and that we think people hold them over the continued existence of species, then this is potentially one of the largest, most widespread, certainly most irreversible cost of climate change. And right now it's kind of still very poorly understood exactly what the cost of that is. And it's certainly not well represented in this social cost of carbon estimate. So what did we do? So in this study, which I think I see the link kind of going out in the chat, and so in this study, we used one of these integrated assessment models. And so the one we used it's called the DICE model. It was developed by William Nordhaus, kind of originally in I think the late 1980s or early 1990s. And so he several years ago kind of actually won the Nobel Prize for among other things, the creation of this model, which was really early effort to try and understand the economics of climate change. And it's still really the main game in town in terms of how to model these things. And so we took his this integrated assessment model, and we made a number of changes to try and better represent the benefits that people get from natural systems. And the main change we did was pulling out natural capital as a separate contributor to economic production and to human utility. And so the standard DICE model kind of thinks of economic productivity as coming from two main factors. So coming from labor and coming from capital. But actually, there was a long debate in the 1970s that about whether should there be a third factor of production, right? Should there be land? Should there be labor, capital, and then land or resources or natural capital, right? And that was kind of resolved, at least partly, in the late 20th century, as no, people really thought that you could just think of, land or resources as a different form of capital, kind of fully substitutable with money. But if that's not true, then that's quite important. And so we pulled out a stock of natural capital, and so then we allow economic production to depend on three things. So it depends on labor, it depends on capital, and it depends on natural capital. And so that then, because that represents the kind of ecosystem service value of natural systems, right? In that the economic production coming out of that is dependent on natural systems because it depends on natural capital. And that in turn kind of contributes to human welfare. Then the second change we did was to try and better account for these non-use values, right? These existence and bequest values that really aren't associated with production in any real way, because people might never kind of interact with these species or interact with these ecosystems. And to do that, we modified the utility function. And so in the classic kind of economic representation, utility depends just on a kind of single consumption good. So it depends on kind of how much, kind of generic stuff you're able to consume. And so that's essentially kind of thing it's a measure of kind of how wealthy you are. But if instead it also depends on other things, so if it also depends on these kind of non-use values that people hold but kind of don't consume, then you want to modify that utility function to kind of represent that. And so in order to do that, we allow the natural capital stock to enter directly into the utility function. And so what that does, it kind of represents the fact that, maybe people, do hold these existence values over the natural capital stock. And then finally, we allow the final kind of key change then is we also allow climate change to directly affect the stock of natural capital. And that represents these kind of what we know kind of about these ecological changes, that temperature does have a negative effect on these on the stock of natural capital. And so these three modifications have a very large effect. And so what they do is they increase the social cost of carbon by a factor of 5. And what it does, that because the cost of climate change are much larger, because you've accounted for this unique role that natural capital plays in economic production and in human utility. And so what it does, those much larger damages, then again also really change the optimal climate policy trajectory. And so rather than what Bill Nordhaus used to call the kind of climate policy ramp, which is where emissions kind of very gradually kind of slow, emissions growth slows, emissions peak around 2050 and then begin declining. If, in this what we call the green dice model, optimal climate policy involves very rapid kind of near-term reduction in emissions. And so much more ambitious climate policy is warranted because although it is very costly, right, the cost of that climate policy is kind of greatly outweighed by the damages that you can avoid by limiting climate change. And so, in our kind of optimal, in this green dice model, the optimal climate policy really stabilizes, it reduces emissions to 0 very quickly, and stabilizes temperature kind of well below 2 degrees, which is the goals of the Paris Agreement. So with that, we're kind of almost at 12:40, and so I think the key takeaways, I think, is that there is regulatory importance as well as scientific importance in understanding kind of in aggregate what does climate change mean for human welfare. The kind of science and economics of that is still evolving very quickly, and and it's definitely not settled at the moment. But also that it is becoming increasingly clear that the damages are large. They're certainly much larger than currently represented in a lot of these models, and that the benefits of really quite ambitious climate change policy is almost certainly going to outweigh the costs, in a way that even just maybe 10 years ago it was not. I would say the economic community was not fully convinced of that. I think the vast majority of economists kind of now are. A lot of that is to do with this literature that I've just described. So thank you for your attention. And I'm happy to kind of take questions through, I guess, the Q&A function.
Okay, thank you, Fran. That was fascinating. And it got me thinking, this is not a question, it's a comment, that Tahoe has a $3 to $4 billion per year economy based on ecotourism. And so the idea of how that may change or what that may cost going forward on account of climate change is interesting. But I think I'd rather focus on other people's questions. So here's one, and I'm going to read it verbatim. And actually, if you can answer it, if you could explain more the nature of the question, that would help everybody. Dr. Noah Kaufman and associates at the Columbia CGEP have proposed a, in quotes, near-term to net zero approach as an alternative to the social cost of carbon. What do you think of this alternative approach? And if you could explain what that means, it would help.
Yeah, that's a great question. I know the paper, I know Noah, and so it's a really interesting debate, actually, and it gets at this question of kind of what exactly are we trying to do here with climate policy and how we incorporate these things into decision making. And the social cost of carbon approach that I just described is a cost benefit exercise. And so you're trying to kind of come up with the benefits of reducing emissions by valuing these kind of the costs of climate change. And then the idea is, well, that would then guide policy into kind of an appropriate level of ambition such that the costs of climate damages are kind of, on the margin are equal to the cost of emissions reduction. There is another approach which says that, well, this exercise is like this is just a bad thing to do and we shouldn't do it for, among other reasons, the very, very large uncertainty in trying to pin down what these damages are. And I am, having worked on trying to quantify these damages, I am fully sympathetic to that point of view. And so this alternative approach would say, well, what we should do is we shouldn't even worry about these benefits of reducing emissions. What we should do, we should just pick a target, we should pick a target by which we need to get to, net zero emissions. And, well, what target should that be? Well, who knows, but like we should pick one. And it should be, kind of consistent with presumably the goals of the Paris Agreement, and what we kind of want, where we want to stabilize temperature. And then from that, you can back out, well, what is a cost minimizing path to get to that emissions reduction? And then you can say, instead of using a social cost of carbon, you can use what I would call a shadow cost of this regulation to evaluate alternate kind of emissions reduction goals or policies. And so if emission reduction policy is kind of more expensive than that shadow cost, then it doesn't kind of then it's kind of too expensive. It's not kind of cost minimizing. But if it's less expensive, then it kind of meets that criteria. And this is what countries that kind of more have their act together in terms of having kind of net zero targets, like the UK, this is the approach that they're using. And they're kind of saying, like, we know climate change is bad. We don't need to know exactly how bad. We don't need to calculate the social cost of carbon. Instead, we're going to like pick a net zero target, and then we're going to, use the shadow cost approach to evaluating alternate policies. And so I think that is a good, I have nothing to say against that approach. I think it's trying to do a different thing in that the social cost of carbon approach I described is very much applied. The real application for it is in, frankly, like relatively small regulations. So it's like things that affect, that happen, that don't have a very large effect on emissions. And so the US economy going to net zero would not be a marginal change in emissions, and it would actually be wrong to use a social cost of carbon approach to value that change. It's much more used for things like adjusting, efficiency standards for refrigerators, or, requiring methane, changes in methane flaring from the oil and gas industry, where I think it does, it's certainly like a perfectly viable kind of number to use in the context. I don't think it has as much to say about these much larger kind of social goals about what temperature should we aim for, what, our net zero targets are kind of very long-term temperature trajectory. But great question, yeah.
Okay, so you mentioned methane, which is a nice segue into this next question. You talked about the cost of carbon to agriculture. What about the cost of methane and nitrous oxide emissions from agriculture on global warming?
Yeah, that's a great question too. And so the interagency working group, which is the cross-federal government group that came up with a federal social cost of carbon, also came up, in later years. It wasn't in the first round of it, but in later years came up with also a social cost of methane and a social cost of nitrous oxide. And I don't remember off the top of my head what they are, but they're big because those are very, highly active greenhouse gases. More so than, definitely the cost per ton is higher than CO2. There's just a lot less of them. And so those can be used, and the process for coming up with that is very similar. So it kind of also involves kind of trying to understand the damages kind of over time, and then kind of integrate discount back using this discount rate. And so those are out there, and you can, if you like look up kind of the interagency working group, social cost of methane, social cost of nitrous oxide, you'll find them.
I'm sorry about that. I lost.
Uh-oh, since he's frozen, I'll go ahead and give you the next question.
Oh, thank you.
The connection. Now
Oh, you're back, Jeff. Go ahead.
I'm back. Okay. It says my internet is unstable. that seems to be a common occurrence. I'm just looking for the next question here. What are your thoughts on the direction of where carbon sequestration is headed? There's been more of a focus on carbon capture storage or technology rather than nature-based solutions.
Yes, I think you're going to see a lot more discussion of this because a lot of companies and increasingly governments have these net zero targets. They are very ambitious targets. Frankly, I don't think we know how to meet them without a large amount of negative kind of offsetting type activities at the moment. And so I think you're going to see, you're already seeing kind of a lot of interest in it. I think it's dangerous to some extent. I mean, I think ultimately the problem of climate change is the problem of, energy use primarily. And if we don't solve that, we're not going to solve the rest of this. And, the accounting, the role of ecosystems is really important, not just for kind of net zero targets too, but just for understanding like the carbon cycle and this question of, we've historically the terrestrial, carbon has been taken up from the atmosphere by terrestrial vegetation. Is that going to change in the medium term as we see more kind of drought and wildfire kind of releasing a ton of carbon stock back into the atmosphere? I think that's a really important question. The question of what role it plays in policy, I am personally dubious of offsetting programs in particular. I think they set up like quite perverse incentives. They are very hard to monitor well. They're very hard to, and so what you're saying if you're thinking about offsets, you're saying, well, I'm going to allow you to kind of burn this coal over here, if you kind of invest in some like forestry project over here. And I think it's great to say, well, we should be doing these forestry projects. And I think that's good. But the idea that we should use that then to do more kind of fossil fuel emissions, I think is very dangerous. And it has the potential to kind of really undermine the integrity of some of these carbon markets. And so I think we thinking of it in those offsetting terms, I would try and get away from. And the more we can think less of net zero and more just zero, I think it's going to be good for everyone, while still recognizing the really important role that these ecosystems and good ecosystem management plays in managing carbon stocks. And we're going to have to get better at that in the future and do that better. And as we all know from our experience of wildfires here in California.
So I guess a number of people have asked if there is a PowerPoint presentation at all. And I think the answer is no. Is that correct?
That is not for this lecture. But I could send other related PowerPoints if there was interest. It would, but I could not. I just didn't have access to my files to be able to pull what I just talked about into a PowerPoint this morning.
Understood. We're all at the mercy of PG&E ultimately.
Yeah, they said the power would be restored 2 hours ago. Yeah.
So. If biodiversity supports all other ecosystem services, then species loss is more than just a question about existence value. Is that true or not true?
Yeah, and I mean, this is where I kind of defer to my ecologist colleagues on this. And on this project I talked about, I talked about one paper, but it's part of a larger project where we're working with ecologists at Davis to do this. And this question of how does, and this in fact, we have a postdoc on this project right now kind of looking into this question of how does biodiversity support ecosystem service provision. And my understanding is that that is still kind of a question within, the degree to like how much, how exactly does biodiversity kind of contribute to this ecosystem service functioning? I think it's still an active question, but it's absolutely right that, to the extent that is also a component of this ecosystem service functioning, that the extinction risk then would play a role in the use values as well as these non-use values. Our modeling that I described was like so abstract that we really kind of didn't have to resolve that question of what we've done so far. But I think it is a kind of active area of research is my impression, and I think something we're going to think about more in the future.
Is the insurance industry using the social cost of carbon for premium setting? And if so, are there any sectors it's being applied to and any conspicuous absentees?
Yeah, these are great questions, by the way. That is a really interesting question. So I guess there are two answers to this. So on the insurance side, well, what's really fascinating to me is like in the last, even just like 3 years, I think you've seen a real wake up among financial institutions in general about, on the one hand, climate change risk. So just the damages from climate change and the fact that, people and community and governments and companies are really exposed to these poorly understood climate change risks. And on the other hand, the idea that, well, governments are getting serious about climate change, and that means fossil fuel assets, or what used to be assets, are increasingly a liability. And that companies that have a large number, kind of have a big, component of their value in long-lived fossil fuel infrastructure are in a risky financial position. And you're seeing the federal government, the Securities and Exchange Commission, the credit ratings agencies, all these institutional investors, all of them are starting to pay attention to both these types of risk. Insurance industry in particular has been doing this for longer, because particularly the reinsurance industry, right? Because they are really concerned about these low probability events to the extent they become more frequent. It's the reinsurance companies in particular are like highly exposed. That is not quite a social cost of carbon problem. What they are much more concerned about, they're not worried about this kind of aggregate risk. What they're concerned about is particular risks, right? And particularly kind of insured risks and the extent to which they're becoming more common, in which case those risks you would expect to be incorporated into premiums that companies or individuals might face eventually. But those are still like that there's an industry called the CAT, short for catastrophe industry, the CAT modeling world, and historically they have mostly modeled hurricanes and earthquakes, is my impression. And they help with estimating what those premiums should be on these highly unlikely but highly consequential events where you don't necessarily have a really good statistical record like you do with, say, like typical house fires, right? You can get a kind of actuarial record for those things, but for hurricanes, for earthquakes, you can't, so you have to model it. And there's a relatively like small group of companies that do this. Increasingly, that you're starting to see companies that do more kind of climate change risk on that side as well. On the other side, on this, what they call transition risk. So this is a risk associated with having these like fossil fuel like liabilities on your books. You're going to see more disclosure. Then, so this is where the social cost of carbon might come into play more. In that, if you think governments are going to start having climate policy that's more or less consistent with what the social cost of carbon is, then you're going to want to start to see those fossil fuel assets kind of pass a test where there's a social cost of carbon, kind of like how valuable are these things if there is a, say, carbon tax at a level equivalent to the social cost of carbon. And I think you're going to start to see kind of disclosure requirements coming in from the Fed, from the SEC, from other financial institutions are going to want to see, companies kind of dealing with that question, because it's becoming obvious. The political system is getting more serious about this, not just in the US, but in other countries as well.
Well, it seems that we have probably another 3 hours worth of questions stacked up, but unfortunately we're not going to be able to extend this any longer. But it seems that it would be really beneficial to have Fran back, not virtually at Tahoe, but in reality at Tahoe at some point in the future. So again, my apologies to people whose questions couldn't be answered or comments couldn't be addressed. Thank you so much, Fran. This was great. I know you prepared this under challenging conditions, and we all appreciate the effort you made today. To everybody else, thank you for attending today, and we look forward to seeing you at future Science Speak seminars. All the best, everybody.
Thank you, everyone.